price of an apple is 10 kwacha and the price of the banana is 5 kwacha. The consumer's utility function is given by, here's our utility function, a to the power 0.5, b to the power 0.5. Okay, this just means that we prefer them both. We give them the same we don't prefer one over the other. That's why it's 0.5, 0.5. Okay, you don't prefer one over the other. So, part A, write down the consumer's budget constraint and set up the Langrangian function to maximize utility. Okay, so first things first, the budget constraint. Okay, budget constraint. All right, here it is. Price of apples times quantity of apples plus the price of bananas times the quantity of bananas equals your income. Okay. The price of the apples is 10 kwacha. Quantity of apples is A. The price of bananas is 5 kwacha. The quantity of bananas is B. Our income is 500 kwacha. Okay, so this is our budget constraint equation. Okay, any questions, colleagues, on this part? Okay, so these kind of questions is also in a step-by-step basis. Okay, step 1, your utility function already be given to you. Okay, step 2, get your budget constraint equation. Once you have these two, you can set up your Langrangian function. Okay, as I said, this Langrangian function is just, you're trying to maximize something when you have limits or constraints. Okay, here our limit is our income, the 500 kwacha. So we're trying to maximize our satisfaction. Okay, so this Langrangian function, this is how you write it down first. Oh, the first thing you do before you write the Langrangian function, your budget constraint equation. Okay, what you do is take this 10a, take it to this side so that it becomes minus 10a. This 5b, take it to this side so it becomes minus 5b. Okay, you're going to see why once we start doing the differentiations. Okay, once you set your equation, okay, just take a, your whatever the price and quantity of the goods that you have, just take them to the other side. Okay, so that your equation looks like this. Okay, 500 minus 10a. Okay, then this function is just a combination of the utility function plus the budget constraint.
Yes, sir. According to the first example that you, or the equation you gave for budget constraint, you mentioned that it is income equals to price of X times quantity plus the price of good Y times quantity. Then here I've seen something that you have written like a 0 equals to the income, then minus
this part, because this expression, as you can see it like this, is going to be put like this in the Langrangian function.
Why will it be put like that, sir?
Because if you don't put it like this, you have difficulties deriving as we go in the later steps.
What if we had been given the quantity? For example, we had put our income as 500, which is equals to the price, which is 10. Then the quantity we have also been given a certain digit of a number. Will there still be need of us to
No,
bring up there?
no, there won't be a need for that. If you are given the quantities, then you have defeated the whole purpose of the question, because the purpose of this question, as you are going to see, we want to find out how much apples and bananas this consumer can have so that they get the most satisfaction.
Okay.
Yes. So
Maybe I'm behind because I didn't see the question too well.
Okay, here's the question here. All right. The consumer has a budget of 500, consumes two goods, apples and bananas. Okay. So as you can see in part B here, this is where we're going to find the quantities.
Okay.
Yes, in part B, you are going to find the quantities. So as I said, these questions is just follow the steps. Okay, it's a step by step process. Step 1, first write your budget control. Your utility function will be given to you. So step 1, write your budget constraint equation. After you write your budget constraint equation, take, like here, this 10a and this 5b, take them to this other side so that you can put it in the Langrangian function. Okay. You take them to this side. Don't take the 500. If you want, you can take the 500 this side. What's just going to happen is your lambda will be negative. Okay, if you take the 500 to the other side there, you have a negative lambda. Okay, and if the question asks you for to get lambda, then it will be hard to interpret. This lambda I'm talking about, colleagues, is this sign here. This sign here, this lambda. Okay, what it's just telling you is how much your satisfaction will increase for every 1 quarter you increase in your income. Okay, if you increase your income by 1 quarter, your satisfaction will increase by this amount. That's what this lambda is. Okay, colleagues, in the Langrangian function, put your lambda. Have this now put lambda here. Utility function first, lambda, then your budget constraint equation here. Okay, utility function, lambda as your budget constraint. Are we okay with this part here, colleagues? Any questions? We'll move to the next part. Okay, so that's part A. Okay, we've set up the function here. This is the function that they wanted us to set up here, like this. And we've already got our budget constraint equation. Okay. Part B, derive the optimal consumption bundle A, B that maximizes utility. So we're just asking how much of A and B do we need to have so that we get the most satisfaction. This is what this topic is basically about. Okay, consumer theory, how you as a consumer with your budget, how you can maximize your satisfaction so that you are happy. So this is where part B begins now, because we are going to need now to derive this function here. Okay, before deriving it, just distribute the lambda to these other terms. Okay, like this. Lambda times 500, you have 500 lambda here. Lambda times negative 10a, you have negative 10a lambda. Lambda times negative 5b, you have negative 5b lambda. Okay. Once you've set up your function like this, then the next step is you need to do partial differentiation. Okay, you need to do partial differentiation. So we're going to first partially derive our function with respect to a, meaning if a number doesn't have an a attached to it, okay, it disappears. Okay, so like this 500, it will go. This 5b, it's going to go. This 10a and this a to the power 0.5, b to the power 0.5 are the ones who derive. Because this b and this a are attached, so the b is not going to go away. Okay, the b is not going to go away. You just derive the a. Okay, so let me just do it here. So you have a to the power 0.5, b to the power 0.5. Okay, so we derive. So for a, you're just going to say this 0.5, this one here, multiplied by the magical one, the invisible one here. 0.5 times 1, you get 0.5. Subtract a 1 from this 0.5, you remain with a to the power negative 0.5. A to the power negative 0.5. Okay, then b to the power 0.5. Are we okay with this differentiation, which is this expression here? Okay, when you derive a to the power 0.5, b to the power 0.5, this is what you get. Any questions? Then this 10a lambda, this a is to the power 1. 1 times negative 10, you get negative 10. 1 minus 1, that is a to the power 0. Okay, so a to the power 0 is the same as 1. That's why you remain with negative 10 lambda like this. Okay. And you equate this to 0, okay, colleagues? After you have derived, equate it to 0, right? And you label this as equation 1. Any questions? Okay. Next, we're going to derive with respect to b. We'll do partial differentiation of our function with respect to b. Okay. So here, 0.5 times 1, you get 0.5. You subtract a 1 from the 0.5, you get b to the power negative 0.5. Okay, a still remains to the power 0.5. Okay. This 500 hasn't got a B. This 10a lambda hasn't got a B. This negative 5b lambda, this b is to the power 1. 1 times negative 5, negative 5. Subtract a 1 from the b, you have b to the power 0. Okay. So once you've derived, you label this as your equation 2. Any questions so far? Alright, even lambda, okay, you are going to derive this function with respect to lambda. So this a to the power 0.5, b to the power 0.5 goes here. Lambda to the power 1, 1 times 500, that is 500. 1 minus 1, you have 500 lambda to the power 0. This negative 10a lambda, lambda to the power 1, 1 times negative 10, negative 10, subtract a 1, lambda to the power 0. Okay, so here the trick is just this. For lambda, just remove the lambda sign and you see you get the original expression we had for our budget constraint. Okay, just remove the lambdas, that's all. Okay, now this equation will only come in handy if the question asks you to get the actual value of lambda. Here what we're trying to get is the value of apples and bananas. Okay, so we're going to focus on equation 1 and equation 2. Okay, yes, so basically you will say divide equation 1 by equation 2. Okay, divide equation 1 by equation 2. Okay, as you can see here, this 10 lambda and this 5 lambda, I just moved them out of the equal sign here. They came here. Okay, let me put it like this here. This negative 10 lambda goes over this side. That's why you have seen I've written it like this. Negative 0.5 a to the power negative 0.5 b to the power 0.5 equals 10 lambda. Okay, similar for where we're deriving with respect to b. This negative 5 lambda also, just take it over the equal sign. That's how it's coming. Okay, so basically take the lambdas by themselves, leave the a b's to themselves. Any questions before we move further? All right, so now here pay close attention, because indices are going to apply, because we have to simplify this expression now. Okay, so after I say divide equation 1 by equation 2, we have to simplify. Here 0.5 and 0.5 cancel each other out. A to the power negative 0.5 divided by a to the power 0.5. If we use the laws of indices, when you're dividing the same base, same letter or same number, you subtract the exponents. So for a, it's the same as saying negative 0.5, this one here, minus 0.5 here for a. Then for b, okay, it will be this 0.5 minus negative 0.5. 0.5 minus negative 0.5. Okay, then over here lambdas cancel each other out. 10 divided by 5, that is 2. Any questions, colleagues? Negative 0.5 minus 0.5, you get a to the power negative 1. 0.5 minus negative 0.5, this negative and negative make positive, so it's the same as 0.5 plus 0.5, we have b to the power 1. Equals 2. Then again, indices, laws of indices. When you have a negative index here, a negative power, it goes at the bottom. Okay, a to the power negative 1 is the same as 1 over a. Okay, so here is the same as 1 over a multiplied by b equals 2. And that's how we get this expression, b over a equals 2. Any questions? Okay, so here you make it. You can make any the subject of the formula. Okay, if you want, you can make A the subject of the formula or B. Okay, so if we cross multiply, a times 2 is 2a, so you can say b equals 2a. Okay, or if you wanted to make a the subject of the formula, a equals b over 2. Okay, so once you get this expression here, okay, once you've done all the derivings and simplified everything and you get this expression, you substitute it back into the budget constraint equation. Okay, colleagues, remember 10a plus 5b equals 500. Now since b equals 2a, so it's 10a plus 5 times 2a equals 500. 5 times 2a, that is 10a. 10a plus 10a, 20a equals 500. To get the value of a, divide both sides by 20, so a equals 25. Okay, 25 apples. So for this consumer to get the maximum satisfaction, they need to consume 25 apples. Okay, they need to consume 25 apples. Okay. Any questions before we get B? Okay, B equals 2a, so a equals 25, so it's a 2 times 25, that is 50. So he has to eat 50 bananas, 25 apples and 50 bananas. Once this combination will give this consumer the maximum satisfaction. Okay, and we can test it in the budget constraint equation to see if it holds true. Okay, our budget constraint 10a plus 5b equals 500. So if you buy 25 apples, 25 times 10, that will cost you 250 kwacha. If you buy 50 bananas, 50 times 5, 250 kwacha. 250 plus 250, 500 kwacha. Okay. You should use up all your money and you are satisfied. So for this consumer to get the most satisfaction, you need to buy 25 apples and 50 bananas. Okay, so let me go through the steps of how you do these questions so that we remember. Okay, a recap of the steps. Step 1, budget constraint equation. Form it. Okay, form the budget constraint equation. Once you form the budget constraint equation, just make some adjustments for the Langrangian function, meaning just take these terms to the other side. Okay, as I've said, 10a you take it this side, 5b you take it this side. Okay, once you're done with step 1, you've got your budget constraint and made that adjustment. Step 2, you set up this function here, the Langrangian function. Okay, it's just a combination of the utility function and the budget constraint inclusive of lambda. Okay, so you just give whatever utility function you have been given, you write it down, plus lambda. Lambda is telling you how much your satisfaction will increase if you increase your income by 1 kwacha. For every 1 kwacha you increase your income for, you increase your income, how much satisfaction you get. That's what lambda is telling us. Then you put the adjusted budget constraint equation here. Okay, that is step 2. You have set up your function. Step 3, derive. Do the partial differentiations with respect to, in this case, with respect to A, B. Okay, lambda, it's really optional because in the question they really don't ask for lambda, so your best just do for A and B. Okay, derive. All right, and you get your expressions. Have you seen this expression here? Here. Get, these are your first order conditions. Basically, these are called your first order conditions. Okay, derive with respect to A. Alright, if you want, this is the point where you can even take this negative 10 lambda, take it over the other side, because these first order conditions you're going to divide them, so take lambda to the other side. Even for B, you get B's first order condition. Here it is. Okay, you derive with respect to B and take your lambda to the other side.
Yes, sir. Where is this lambda coming from?
When we set up the function, the Langrangian function, you introduce lambda.
Okay. Then when does this negative 0.5, which is the power of B coming from, or the power, these powers which tends to tend to negatives?
When we're deriving. Okay, so that's how those negatives are coming. Is that okay, Mr. Aleni?
So request we derive together so that I
So
get.
where were you when I was deriving? I derived in this video. I was deriving in this video, sir.
I was taking note of the something. Now I didn't get clear on the time you were deriving.
Okay. Unfortunately, because I've got another class pending, so I'll just say watch the video. Because here I'm just going through the steps, just summarizing the steps. So once I post the video, just watch the video. You're going to see how I was deriving, do the partial differentiation. So we're on step 3, where you get your first order conditions, where you derive this function with respect to a or b or x or y. Step 4, after you have derived this, you label this is equation 1, equation 2. Step 4, divide equation 1 by equation 2. Okay, put it like this here. Divide equation 1 by equation 2 in this format here. That is step 4. Just hold on. Step 5, simplify this expression. Okay, you need to simplify this expression. The lambdas will cancel each other out. You simplify so that you get an expression like this. Okay, because you are trying to find b and a, so you want to make you want to either make a or b the subject of the formula. Okay. You want to make either a or b the subject of the formula. So that's step 4. Okay. Then step 5, substitute this new expression into the budget constraint equation so that you get first your value of b or whatever you're trying to look for, then you get the value of a. Okay, so basically 5 steps. Okay, 5 steps.